All right, so we're going to continue to look at logarithms. Our first few examples are pretty similar to what we just saw in the intro video, so we'll just continue working on that. Example 4 says log base 3 of 1. We want to know what it equals, so log base 3 of 1 is equal to something. We rewrite it in exponent form. 3 raised to the x power is equal to 1. All right, so now we have to figure out, well, 3 raised to what power is equal to 1? If I said 3 to the first power, that's going to equal 3, and we need something smaller than 3, which is 1. So we do want to remember an exponent property that says anything raised to the 0 power is always equal to 1. So if you can see that 3 raised to some power equals 1, that means it must have been 3 to the 0 power, just to get that 1 as an answer. So our answer is 0. All right, next example. Log base 3 of 3 is equal to something. So we rewrite in exponent form. 3 raised to the x power is equal to 3. Well, we know that 3 raised to the first power is equal to 3, so our answer is 1. We're trying to figure out that exponent value. All right, example 6, log base 3 of 81 is equal to something. We put it in exponent form. 3 raised to the x power equals 81. All right, so we go through our possible exponents. Is it 3 squared? That's 9. 3 to the third power is 27. 3 to the fourth power is equal to 81. So our answer is 4. All right, so now that we have the basics down, we get to look at some that get just a little bit more interesting. So example 7, we have log base 5 of 1/5. Again, we're going to approach it the same way. We're going to rewrite into exponent form. So 5 raised to the x power is equal to 1 over 5. So what's going to be helpful on this one is to recognize that, well, something made this 5 to the first power go down to the bottom of a fraction. So if we remember that, well, we don't need to do that. We want this back up top so that it looks like this one. So what that means is if you move it, your exponent will change signs. So that's going to be 5 to the negative 1 power. And I'll just carry down my 5 to the x. What that allows us to do is get our base of 5 to match, so that looks the same. So now we know that x must equal a negative 1. So the value of our logarithm is negative 1. All right, another kind of similar one with a fraction. Log base 3 of 1 over 27 is equal to something, so we will rewrite in exponent form. 3 raised to the x power is equal to 1 over 27. All right, because we're in base 3, it would be really helpful if we wrote this in base 3 as well. So let's go ahead and take care of that first. We have 3 to the x is equal to 1 over, now 27 is this same thing as 3 to the third power. Now let's go ahead and get that up top, which means the exponent changes signs. Oops. So we want 3 to the x power is equal to 3 to the negative 3 power. And then we have the base that's the same, so that means the exponent must be the same because they are equal. So x is equal to negative 3, or the value of our logarithm is negative 3. All right, do we like these yet? Are they kind of fun? You feel like you're doing some fancy math? You should feel good about this. All right, log base 3 of 9 to the square root of 3 power, 9 times square root of 3 power, is equal to something. So let's work through this and see what's going on. We have 3 raised to the x power is equal to 9 square roots of 3. Okay, so similar to the last one, we have a base of 3 over here, so we want this side to be written in terms of a base of 3. So that 9, I know, is the same thing as 3 squared. And it's being multiplied by the square root of 3. Well, we learned in our last chapter, at the beginning of chapter 10, that the square root of 3 is the same thing as 3 to the 1/2 power. So Now it looks like a multiplication problem with the same base. That means that you can keep the same base and just add the exponents. So 2 plus 1/2, if we think about doing that off on the side, get that common denominator because it is adding fractions. So we have 4/2 plus 1/2 gives us a 5/2, so that is our exponent, 5/2. So 3 to the x is equal to 3 to the 5/2. So we were able to manipulate this 9 times the square root of 3, has the exact same value as 3 raised to the 5/2 power. We just rewrote the 9 with a base of 3 and rewrote the square root of 3 with a base of 3. Now that our bases are the same and there's an equal sign in between, that means your exponents will also be the same. So x equals 5/2, or this logarithm has a value of 5/2.